Very good morning everyone. So far we have discussed very important aspect of the first chapter, that is measurement and the experimentation, like what is meant by the units, what is meant by the measurement, what are the fundamental units, what are the derived units, and how many fundamental units are there, how many fundamental quantities are there, and so on. So if you remember, there were 7 fundamental quantities in the unit. For example, length, time, mass, temperature, and so on. There are 7 fundamental quantities and their unit. In physics, although all 7 quantities are equally important, but here we will discuss some very important quantities unit. For example, we will discuss about what are the definitions of the units of the length, units of mass, and units of time. For example, you know that the unit of length, the SI unit of length is meter. Now, how do we define meter? We will discuss about that. Then you know the SI unit of the mass was kilogram. How do we define the kilogram? Then SI unit of the time was second. How do we define the seconds? So we will discuss all of these definitions, and very important part, we will discuss some smaller and bigger units of the length as well. So let us start with the definition of the SI unit of length. Let's discuss about the unit of length, and you know the SI unit of length is meter. Let us see what is the definition of meter, then I will describe how we set this unit. So the unit, the definition. So the SI unit of length or distance, we know that is meter. How do we define this? A meter was originally defined in 1889, approximately more than 100 years ago, as the distance between two marks drawn on platinum iridium. Now, what is platinum iridium? It's basically, you know, that is a mixture of two words, platinum and iridium, both are metals. So we take an alloy in which 90% it is made up of the platinum and the rest 10% of iridium. So we make an alloy, platinum iridium, taking 90% platinum, 10% iridium, and we mark 2 points on this rod kept at 0 degrees Celsius. Now, why they mention the temperature? You must have studied in the class, I think 7th or 8th, that there is a term known as thermal expansion. If the matter get heated, then its length or its area or its volume increases. So in order to have a constant length, we have to set the temperature at a certain temperature. So we have decided, let's say the temperature is 0 degrees Celsius, right? So if we change the temperature, obviously the length will automatically change, right? And if we change the length, then the actual length of the meter will vary. So we set the temperature at 0 degrees Celsius, right? In the International Bureau of Weights and Measures at Seviers near Venice. Now, let's quickly talk about it. When I started this chapter, I told you the measurement is basically defined as the comparison between one standard quantity and second the given quantity. Now, if I say, how do we know that this is the length of 1 meter? Suppose you go to a shop and you say, I want 1 meter of cloth. Now, who will decide that how much cloth you will get in 1 meter? Who will decide this? Maybe you will go in one shop and they will give you this much of length, and when you go to the another shop, maybe they will give you this much of length, right? So there will be obviously there will be no set unit. So you know, there is an organization known as International Bureau of Weights and Measures what they do, they have decided, if we talk about 1 meter, this is the 1 meter, this is the length of 1 meter. If you go anywhere on this planet, if you go in any country, in any city, the length of 1 meter will be equal at every places. And who decided that? This International Bureau of Weights and Measures. They said, what did they say? They said they have taken an platinum iridium rod, they mark 2 points, and they say from now on onwards, this will be defined as 1 meter. Right? Alright. Now, as you know, this unit this definition was given by this bureau more than 100 years ago. Now, when we advance in physics, we see there are some more important physical quantity which do not change with time, with space, like the speed of light. So they think, why do not define the unit of meter in terms of speed of light? So the latest unit of the definition of the meter is in terms of speed of light. And what is it? It is 1 meter is the distance traveled by the light in 1 by 299,792,458 of a second in air or vacuum, right? So we have changed the unit, the definition of length from 1 meter from this to this. In exam, sometimes they ask, write the definition, so you can, I prefer you will write this one because this is the latest definition. Let's discuss some subunit of meters. Let's talk about some smaller subunits. For example, you know 1 centimeter is equals to 10 to the power minus 2 meter. 1 millimeter is equals to 10 to the power minus 3 meter. 1 micrometer, or we also say it is 1 mu. 1 mu, and mu is called micron. It is equals to 10 to the power minus 6 meter. 1 nanometer is 10 to the power minus 9 meter. There are so many, you know that if you remember, we have done the prefixes in the previous video. In prefixes we have powers of 10. Suppose we talk about nano. So nano was 10 to the power 9 minus 9. So if you have nanometer, that means you have to multiply the meter by 10 to the power minus 9. Like here. Suppose we have micrometer. So in prefixes, the value of micro is 10 to the power minus 6. So if you want to find out the value of micrometer, we have to multiply meter by 10 to the power minus 6. So they are basically conversion factors, right? So you have to remember them. In the previous video, I have covered all of the prefixes, smaller prefixes as well as the bigger prefixes. Now, these are smaller units. We have the bigger as well, known as multiple units of meter. Multiple unit. For example, you can take the example of decameter, hectometer, but you know, most we can say everyone knows about this unit, and it is very important, known as 1 kilometer. And you know that in 1 kilometer there are 10 to the power 3, and that means 1000 meters. So these are some subunit of meter and the multiple units of meter. Now we'll talk about some units known as the non-metric unit. They are not defined in terms of meter, although we can convert them into the meter, but originally they are not defined in terms of meter, right? So let's talk about it. They are very, very important. So I'm talking about the non-metric unit. So in non-metric we have smaller unit as well as the bigger units. Let's talk about the bigger unit first. Now, why we need the bigger units? For example, you know that the distance between Earth and Sun is about 15 crore kilometer, right? Now, when we say 15 crore kilometer, and 15 crore is a very big unit. If you want to find out the time taken by the Earth to complete one revolution, you know the distance between the Sun and the Earth is 15 crore, and time is in second, and then you can find out the velocity of the Earth. So these calculations will be very complicated. And so what we do, we try to minimize these units into a single term, right? For example, when we say 1000 meter, I say the distance between my home and the school is 3000 meter. So instead of saying 3000 meter, I can say 3 kilometer, right? Similarly, if the distance is very large, like the distance between Sun and the Earth, it is 15 crore kilometer, right? Then we can reduce these kilometer into some bigger unit as well. Here we have a new unit known as 1 astronomical unit. In short, 1 AU. So 1 AU or 1 astronomical unit. How do we define this? It is defined as the average distance between the Earth and the Sun is called 1 astronomical unit. And this 1 AU is basically equals to, what is it? If you remember in the class, we have done this. 1 AU is equals to 1.496 into 10 to the power 11 meters, right? So instead of saying the distance between the Earth and Sun is about 14 crore and 9,60,000 meter, we can directly say the distance between the Earth and Sun is 1 AU. Simple. We will not say 15 crore kilometer. We will say 1 AU. And if anyone knows how much 1 AU is equals in terms of meter, they can easily calculate. Now I said the definition is average distance. What does it mean? Average, we find average when quantity changes, right? Suppose a student get 40 marks in physics, 30 marks in chemistry, 35 marks in mathematics, then we find what we do? We find the average of the marks. What we do? Marks of physics plus marks of chemistry plus marks of math divided by the number of subjects. Now we are saying the average distance between the Earth and Sun. It means that the distance between the Earth and Sun is not constant. It changes time to time. For example, suppose this is the Sun. When the Earth revolves around the Sun, it is not revolved in a circular orbit. Because if it is revolving in the circular orbit, then every day the distance between Earth and Sun will not change, and then we will not say that the average distance. So the path of Earth around the Sun is not circular, but it is elliptic. It moves like this. Something like this. Now you see that at certain point, like I have taken 2.1, let this point is P and this point is A. Can you see the distance between these 2 points is different? Suppose Like right now, let's say Earth is here at point P. This is Earth. Can you see this is the shortest, this time it is the shortest distance between the Earth and Sun. This point is called perihelion, right? It is perihelion. And this perihelion distance between Sun and Earth is only about 1.471 into 10 to the power 11 meter. Now Earth revolves around the Sun and it reaches a point A known as aphelion. The distance between the Earth and Sun will become 1.52 into 10 to the power 11 meter. So you see that the distance is not constant. The shortest distance, that is the perihelion, at the Earth is the perihelion, it is 1.471 10 to the power 11 meter, and when it is the farthest from the Sun, it is 1.52 10 to the power 11 meter. So it is not constant. So what we do, we find the average, right? So basically this 1 AU is average of the smallest and the farthest distance. So 1.471 into 10 to the power 11 plus 1.52 into 10 to the power 11 divided by 2, you will approximately get the distance, that is this. So 1 AU is equals to 1.496 10 to the power 11, or approximately 1.5 into 10 to the power 11 meter. So this is how we calculate the distance between the Earth and the Sun. So that's your 1 AU astronomical unit. So if someone say that suppose the distance between the Sun and the planet Neptune, it is at 30 AU, right? It means that suppose this is the Sun here and this is somewhere here, it is the Neptune. The distance between them is 30 AU, right? Now if we don't know what is AU, we have to measure this distance in kilometer. We'll say 30 into 15 crore kilometer will be very, very large unit. So instead of saying kilometer, I will say in AU, right? So we distance, large distance in AU. Now there are certain distance which is, again, it is too large for AU. For example, we say we can say the radius of our galaxy, or the distance between the nearest galaxy, that is Andromeda galaxy. So if we measure in AU, again it will be a very big number. So for more bigger unit, we introduce one more bigger unit known as the light year. So how do we define the light year? So basically 1 light year, it is the distance traveled by light in 1 year in vacuum is called 1 light year. So you know the distance, you know the formula, that distance is nothing but equals speed into time. So let's find out how much light year is. So 1 light year, you know the speed of light in air or in vacuum is about 3 into 10 to the power 8 meter per second. And time, I'm talking about the 1 year. So in 1 year there are approximately 365 days. Now we can't multiply second with days, right? We have to convert this into the second as well. So let's convert it. So 3 into 10 to the power 8 into 365 days. You know, in 1 day there are 24 hours. In every hour there are 60 minutes, and in every minute we have 60 seconds, right? So now I have converted, this is in second as well. So when you calculate, when you multiply all of these, 1 light year. So can anyone, please, you can multiply in your calculator and find the answer. It will be about 9.46 into 10 to the power 15. 9.46 into 10 to the power 15 meter. So can you see it is bigger as compared to the astronomical unit, because remember 1 AU was just 1.5 into 10 to the power 11 meter. This is 15 meter, right? Approximately 10 to the power 4 times it is bigger than the AU. Now there are certain distance, if we measure in the light year, they are again too large to measure the light year. So we get one more unit, one more bigger unit than the light year, and that is known as 1 parsec. And 1 parsec is basically equals to 3 points. See, it is bigger than the light year. 1 parsec equals to 3.26 light year, right? So 1 parsec equals to 3.26 light year. Now what is parsec? Let's quickly, how do we define the parsec? It defines it is the angle. When we say, suppose you consider an angle, right? So let this is a circle, and you take an arc, this, and this arc subtend an angle, let's say theta. You know, this is the radius r, and the arc is s. How do we define parsec? We say, suppose we have a star here, right? And this is the sun and this is the earth. Quickly, just understand this. So this is the sun. You know the distance between earth and sun is 1 AU, right? And there is a star which is making an angle 1 arc second, right? So this 1 AU is subtending an angle 1 arc second. So this distance between the star and the sun will be 1 parsec. Now how do we calculate this? Now very important thing, what is 1 parsec? You know that in 1 degree there are 60 arc minute, and in 1 minute there are 60 arc second. So how do we convert arc degree to arc second? So 1 arc second is nothing but 1 upon 3600 of the degree. Now you know the formula that angle is equals to arc upon radius, right? Now from this formula, this is the angle, which is nothing but it is 1 upon 3600 degree. This is the arc, which is nothing but AU. So this radius will be equals to 1 parsec. So when we calculate this, 1 parsec will be equals to arc, that is 1 AU, or 1.496 10 to the power 11. This is the AU divided by 1 divided by 366 of degree. Now you know we can't directly use the degree, as if you remember I have discussed in the first lecture. We can't use angle and degree. We have to convert them into the radian. So if you convert radian, we have to multiply it by 5 upon 180. So when you multiply these, this will be equals to 3.08 10 to the power 16. 3.08 into 10 to the power 16 meter. So you can see that is again more than the light year. So these are some bigger units of the length, right? If we get the next lecture, I will talk about some smaller unit of length. Thank you so much.